All right, eighth grade, happy Tuesday. We are going to be looking at estimating quantities. So last week we covered magnitude. That was the first lesson of the second half of our unit. Now we're going to be estimating quantities. Okay? So just a little review from last week with magnitude. So we looked at really big numbers. I'm not going to read it to you. Then finding the smallest power of 10 that exceeds that. So based on the number of digits, because it's smaller than all the nines and then the 1, however many zeros it is. And then same thing here, smallest power of 10 that exceeds m again, okay? So here we have, in 1723, the population of New York City was approximately 7,248. By 1870, almost 150 years later, the population had grown to 942,292. We want to determine approximately how many times greater the population was in 1870 compared to 1723. So approximately is not precise, so we approximate both as powers of 10. So same as we did last week with magnitude, 7,248 is smaller than 9,999, which is smaller than 10,000. So we can represent that approximately as 10 to the 4th. And again, I'm not going to read the numbers, but so we have this population of New York City in 1970 that's smaller than this, which is smaller than 1 million. So we can represent it by 10 to the 6th. So again, here, so we want to compare the population in 1870 to the population in 1723. So we're going to represent it as a fraction of 10 to the 6th over 10 to the 4th. 10 to the 6th, again, is the 1870. So what does that mean? So this is another law of exponents, which we talked about in the first half of the unit. So when dividing numbers in scientific notation, subtract the exponents. So we have 10 to the 6th over 10 to the 4th. So 6 minus 4 is 2. So the difference is 10 to the 2nd, which we know to be 100. So there are approximately 100 times more people in New York City in 1870 compared to 1723. So work on this one on your own. That should be all of 2013. Guess I need to proofread a little better. So when you're ready, hit play to see the answer. We have the Federal Reserve stating that the average household, oops, I'm sorry, I forgot a lot of words apparently. The average household in January of 2013 had $7,122 in credit card debt. About how many times greater is the U.S. national debt, which is a really big number. Rewrite each number to the nearest power of 10 that exceeds it, and then compare them. So we have the household debt to the power, or 10 to the power of 4, U.S. debt 10 to the power of 14. So we take 10 to the 14th over 10 to the 4th, which is the difference of 10 to the 10th times greater. So we can also, again, go ahead and we'll go through this one together. So compare the population of New York City to the population of New York State. New York City, 8,336,697. We round to the nearest million, we round down to 8 million, written as single-digit integer times power of 10. 8 times 10 to the 6th. So now we've added a little bit more to our powers here. New York State is 19,570,261. Rounded to the nearest million, we get 20 million. Again, written as a single-digit integer times the power of 10, 2 times 10 to the 7th. So we want to compare them. So we take 2 times 10 to the 7th over 8 times 10 to the 6th. Okay, so we break it down, 2 divided by 8 times 10 to the 7th divided by 10 to the 6th. So we would take 2 to the 8th is 1/4, and 7 minus 6 is 1. So 1/4 times 10, which we can then figure out, which is 0.25 times 10 equals 2.5. So New York State is 2.5 times the size of the city, as far as population goes. Work on this one on your own, and then when you're ready, hit play to see the answer. So there are about 9 billion devices connected to the internet. If a wireless router can support 300 about how many wireless routers are necessary to connect all 9 billion devices wirelessly. So we're first going to break it down with a single-digit integer and the power of 10. So we have 9 times 10 to the 9th, 3 times 10 to the second for 300. 9 times 10 to the 9th divided by 3 times 10 to the second. 9 divided by 3 is 3. 10 to the 9th divided by 10 to the second gives us 10 to the 7th. So it requires about 30 million wireless routers to connect all 9 billion devices to the internet. That's a lot of Wi-Fi routers. Your assignment is going to be answering the questions for lesson 8 that are on Edmodo. If you have any questions, let me know.